Are we live? Let's see. Yes, we are live. Hello, everyone. We'll get started in just a minute. Um, just opening up the presentation. All right. Um, we'll go ahead and wait a little bit, let people get on, and then we will go ahead and get started. All right, we'll go ahead and get started in like 1 or 2 minutes. Um, if there's any problems with the stream, this is my first time doing anything like this. Just let me know in the chat. I don't know what I will be able to do about it, but I'll try my best to fix it up. So if there's like any audio issues or any like buffering, lagging, just let me know in the chat. That way I can let you. That way I can try to fix it up. Can everybody hear me okay? All right. Perfect. Let's go ahead and get started. Um, Thank you guys all for watching. I mean, I had no idea that this many people would be interested in watching a presentation by us. I'm really excited to show you a little bit about how our team operates and what really changed our team. And so we'll be going over this in this presentation, which is how block programming inspired our Inspire Award-winning team. Um, and so I'm Ishaan Oberoi. One second. I'm Ishaan Oberoi. I'm the captain and robot lead and FTC outreach lead of the team Wizards.exe, located in Rockville, Maryland. We won the Inspire Award at the World Championship in Detroit in 2018, and I'm an 11th grader going into 12th grade. I've done FIRST Robotics for 7 years, and I have developed a curriculum about teaching block programming. And a lot of you are probably thinking, as an Inspire Award-winning team, as a team that may be a little bit more advanced than other teams, why would you use block programming? And that's exactly why I'm having this presentation, because many people don't realize the power of it. I've been doing FTC for 4 years, and block programming completely changed the way that I do FTC. And I'll be talking to you a little bit more about that as we go through the presentation. So this is a little bit about my team. We're Wizards.exe. This is our 4th year. We just completed competing. We won the Inspire Award. And our mission is to engage, expand, and educate people in our community. And that's part of the reason why we do this. We've trained many teams how to use block programming because we find that it really helps educate people about programming, and it helps reduce their frustration, so it helps keep them a part of FIRST longer. I know a lot of you probably have gone to a competition and it's really frustrating because the code just isn't working. That's sort of the reason why we've been doing block programming. We've trained over 100 teams how to use block programming, and a lot of these teams use it in competitions. So that's a little bit about us. But before we begin, if I were normally giving this presentation at a conference or something, I would ask the following questions. How many of you guys have done block programming before? I know a big part of my audience has not participated in any block programming training or used block programming before because they think, oh, it's just drag and drop software. It's like Scratch. So a lot of people just are scared from using it. Um, and how many of you have been given training for block programming? Um, I don't know how many other places have block programming training, and part of the reason why I'm giving this presentation here is because I want to help encourage other top teams around the world and other teams around the world just to teach using block programming to rookie teams. Um, and I think that that's one way that we can help strengthen the entire first community, um, is by teaching others how to use block programming. And then how many of you have had access to block programming training? Um, I Again, I want to increase the access to block programming trainings by um, increasing the amount of people that can do them, which is one of the reasons why I'm giving this presentation today. And after today, I will share all the resources that I've got teaching block programming. That way we can expand this community to be bigger. So these are some of the goals that I'm going to have for going through this presentation. I'm first going to talk a little bit about block programming, what it is, since some of you may not know that. And I'm going to also compare it to Java and OnBot Java, which is one of the things that many people... Oh, I froze. Hmm. Try refreshing your page if you dropped out of the live stream. In my preview, I'm able to see it. I don't know how many other people can see it. Okay, so it looks like it's working fine for some people. Just try refreshing. As always, I'm gonna upload this to YouTube, and it's gonna be there forever on YouTube just for people to view. So if you have any questions, just put it up there, and you can watch this all over again. Sorry about the technical difficulties. Um, so let's go over the goals for this presentation. I'm going to give an overview of block programming. So I'm going to talk a little bit about what it is compared to Java, OnBot Java, stuff like that. I'm then going to talk about how it really improved our team dynamic, especially in the year that we won the Inspire Award. Block programming was key. And then I'm also going to tell you about what you can do with block programming. Because many people think that block programming is limited, but you can actually do everything that you can do in Java in block programming. And then I'm going to give you some resources for block programming, and I'm going to teach you how to give trainings for block programming, because my end goal is to give more trainings and get more people to be able to give trainings for block programming. So I'm going to be trying to spread that out. So what is block programming? And so on the left here, you can see what block programming really is. It's a drag and drop software. It looks a little bit like Scratch if you've used that, or like EV3 if you've used that. And it's a graphical programming interface. And all that you need to run it is Google Chrome, which is awesome because I know a lot of schools are getting like Chromebooks and stuff like that. So having block programming really allows these schools to be able to program FTC robots without having to install Android Studio. Java, on the other hand, which you can see on the right-hand side, is a text-based programming language, and it requires knowledge of syntax and structure. And I'm not saying that's a bad thing. I'm just saying it's something that you need to know before you can go into programming. It requires Android Studio and probably GitHub if you want to make sure that you maintain your version and stuff like that. So there's some advantages to block programming there. But people don't use it because they think it seems too simple. So people think that they can't do everything in block programming and that real programmers don't use a drag and drop programming language. So imagine if I told you that real engineers for mechanical engineering don't use cardboard cutouts, or they don't use 3D printing to prototype, or they don't use any of their prototyping tools. Um, I mean, that just is absurd. Everybody uses prototyping tools in mechanical or like engineering. So we should have some way to prototype our software. And that's what I'm really trying to sell block programming as. It's not just a programming language that you use to replace Java, but it also can be used as a prototyping tool in order to speed up development. And our team, this past year, we used Java. So we used Java for our robot. But that doesn't mean that we didn't use block programming for part of our season in order to prototype stuff. Um, and that's just one of the advantages of block programming. So I'm going to give you a little bit of a background of our team, a little bit of a story. So this is our team in our first year. And we had 8 of us. And of course, everybody wants to work on the robot. So that's what this green circle represents. That's how it is on most teams, and there's nothing wrong with that. A lot of people like to work on the robot. But we only had 2 Java programmers. And this led to a lot of bottlenecks because whenever the hardware team finished a prototype and they wanted to test out their prototype, they would have to wait for one of the 2 of us to get out Java, program Java, create an op mode, and then it would be a week, and by that time you had forgotten about that prototype. So this is really how many people ended up working on the robot. It ended up being 4 people because we just didn't have enough Java programmers to handle that bottleneck. Um, and then again, in our next year, everybody wants to work on the robot. And this year we had some newer members. So we had 11 members total, 3 of which were veteran members and um, 8 of which were rookie members. So there was a bit of a learning curve. But again,
Testing. All right. So, like I've said before, I don't know how much you guys caught, but um, without having enough programmers, let me check. Testing. All right, it looks like the stream is back up. Just send me a message if it goes back down again. Sorry about that. So, like I was saying before, with only 2 Java programmers, it really does not allow teams to work together and everybody to work on the robot because you have no way to test out hardware prototypes. So, what did that lead us to? Our 3rd year. And in our 3rd year, we had a team of 11, the same 11 as our previous year, but this time, everybody wanted to work on the robot, like always. I mean, that's just how it usually is. This time we had 4 Java programmers, which is better, but one of the key advantages that we had this year was everybody learned how to do block programming. And so since everybody could do block programming, that allowed everybody on the team to work on the robot. And it was because we were able to test out our hardware, test out stuff, and everybody felt involved with the robot because they could do block programming, that we were actually able to have everybody work on the robot. And this is something that many teams strive to do, but it's very, very difficult to do. So being able to have everybody on the team do block programming was an incredible feat for us because it allowed everybody on the team to work on the robot. So with that, let's look at our 4th year. This was our current year, last year, Rover Ruckus. So in sorry about that. In our 4th year, again, we had 11 members. All of us wanted to work on the robot. I mean, that's just how it is. 3 of us were Java programmers. We had 5 rookie members on the team this year, which really made it difficult for us to teach people and to have everybody get involved on the robot. And I know from other teams I've heard it's very difficult to get rookies to jump in to get doing stuff on the robot. But again, we had everybody on the team learn block programming, and that allowed everybody to be involved in the entire robot building process. So by having block programming, it really changed the way that our team worked, and it allowed us to be able to have everybody work on the robot together and feel like they contributed to the robot. I know once we had block programming, it made people feel like they were more of a part of the team, and it completely changed our team dynamic. So how do we currently use block programming? So we prototype algorithms in block programming before we go into Java. I mean, let's say I want to test out a sensor, like when they released the Rev IMU, I wanted to test that out. So I quickly wrote some block code to make sure that the sensor was working and to make sure that I could write algorithms like a PID loop. I just wrote that in block programming before I went to Java, since the development is a lot quicker in block programming. We also tested out sensors, motors, hardware devices. Just like I said before, in competition, we have a diagnostic test, which is effectively we try out all of our hardware to make sure that it's all working. So we test out our sensors, our motors, stuff like that. That's all written in block programming. We test out all of our mechanical prototypes in block programming without the programming team. And that's really changed our mechanical team because it allows us to rapidly prototype without having to go through the hassle of waiting for our programming team to program the prototype and then finding that the code doesn't work and then finding that the prototype doesn't work and that entire process taking a month. This definitely sped up our development time and it allowed us to be more successful at competitions. So block programming can also be used for outreach, and not in just training, but also for demo robots. So if you see that robot there, that robot's actually Gandalf, which was our robot from Velocity Vortex. And Gandalf, we take him to outreach events because kids love to see robots shoot. And it's hard to maintain the code in Java on Gandalf because, let's say, we want to use those phones that Gandalf has for a different purpose, and we rewrite the code in Java. that makes it very difficult for us to have the code ready for outreach events. So what we do is we just program it in block programming on the spot at the outreach event before we get there, or when we're there. We can finish a block program in less than 30 minutes. And so within 30 minutes, Gandalf is up and running, and it's able to shoot balls and be a real crowd pleaser for all of the children that come to our outreach events. So even though we had a lot of new team members this year, um, they were able to contribute to training block programming in less than 3 weeks of learning it. So the person standing on the left, in the picture on the left, that's Ayush. He joined our team for the first time this year. He had a little bit of programming background. I gave our training to him, and within 3 weeks, he was training other people how to do block programming because it really changed the way he did it. Sudesh down there, he's a 7th grader. He's on the right. He's a 7th grader. He's never done FTC, never done robotics before.
One of the cool things is that he was able to teach block programming within he was able to teach block programming within 3 weeks, and he was able to help lead a training, which was pretty awesome for him. Being a rookie member, it can be very daunting to do something like that, and because of how simple block programming is, it allowed him to be successful that way. All right, am I still live? Just send a message in chat. Am I still live? All right. So now let's go to how we spread it to others. So we tried to train other teams, and so we've run about I think we ran 3 trainings this year. We ran 3 trainings the year before about block programming. And this is what some of the teams had to say. The team Aces was inspired by our block programming training, and they went back home and worked all weekend long. And one of the things that we find with block programming is it really motivates a team, because what happens is they get to see their robot working really quickly. So within half an hour, we can get a team running a teleapp program in block programming. And so that really motivates them to continue working and try doing advanced things. So this team, they were working all weekend long after we gave them a training where they were able to do a little bit of autonomous. Fracture Critical, they were in Pennsylvania. They said that they had spent the entire summer trying to get their phones paired up, getting the robot just moving. And in 2 hours of training, we were able to teach them all of that. So block programming can really change teams, and it can really reduce frustration. So that's one of the reasons why we just highly recommend it. So also, going to competitions, I know that you guys have all been to a competition where there's 4 teams on the field and none of them run autonomous. It just happens. That's FTC for you. And because none of them run autonomous, there's just 30 seconds of sitting around doing nothing. What we do is we go to competitions and we help other teams get a simple autonomous program running in block programming. So we will go, we've made these handouts. I'll share all these handouts with everybody after the presentation. And with these handouts, we go around and teach people how to make their drivetrain move or how to program a teleapp program, all in block programming. And so, like this year, we were able to help a team delatch their robot. So they had a hanging mechanism on, but they couldn't figure out how to do an autonomous program to delatch. So at a competition, we went up to them and we helped them get their robot delatching. And it was awesome because they actually beat us in the next match. But that's what FIRST is all about, helping other teams beat you at their best, because you really want to see the program grow. And I think it's not only rewarding for them because they get to see what success is, but it's also rewarding for you because you get to see where your success is going. You're helping teams be successful and motivating them to continue with STEM. So some details about block programming. I know I've been talking about it really generally. So all that's required is Google Chrome. There's no experience required. There's no syntax error, which is awesome. It's almost impossible to make a block programming code that crashes because of a syntax error. There's very few ways to do that. And it's very user friendly because it's very graphical. Many of the people doing FTC are visual or tactile learners, and the graphical aspect of block programming really helps with that. And this is something that many people understate about block programming. You can wirelessly code upload to your robot. With Android Studio, there's a whole complex process in order to set up wireless debugging. And even when you do set up wireless debugging, what happens is it takes about 1 to 2 minutes to download your code. I know I've been there. Our programmer is programming in Java, and he downloads the code, and it takes like 2 minutes. And then he runs the code, and he realizes, oh, I forgot to open up this servo. And so then we have to wait another 2 minutes for him to download the code. And there, we've already wasted 5 minutes because we just weren't using a quick development cycle. The wireless downloading of code in block programming takes less than 10 seconds to download almost any piece of code. So it's much quicker in that way. Our coach, he does not know how to program in Java, and he was able to program block programming within a few hours. So that's the awesome thing about it. You need no background knowledge in order to be able to program in block programming. I mean, of course, programming Java will help, but anybody can pick this up. And that's one of the advantages of it over Java. So what are the keys to success on learning blocks? So one of the things that I think many teams don't realize is that block programming is great, but it's really understanding how the control system that sets your team up for success. You need to have your team know how the electronics work, how to pair phones, how Wi-Fi Direct works, what the Rev Hub is, what modern robotics is, depending on what you're using. So understanding how everything connects up together is a very, very important part of learning block programming. So block programming really helped teach our team why it's important to configure the robot properly and what's important about robot configuration. Earlier, we would tell some of our rookie members, hey, can you create a robot configuration for this robot for me? And they would do it, and their names would be out of place. They would misdo some of the ports. And then when the Java programmer came along and was ready to program the robot, the configuration was completely messed up. So then we had to redo the configuration. Using blocks really helped teach these rookie members the importance of configuring your robot and how to maintain proper naming schemes so then you don't actually maintaining proper naming schemes so then you can actually keep track of all the hardware connected. So what we do as a part of our block programming training is we have everyone learn how to configure the robots, the phones, and how to pair them up, because that's one of the most difficult things in FTC. Yeah, the programming's hard, but the harder thing is how do you get two phones to talk to each other over Wi-Fi Direct? So everybody on our team can do that now, and that not only helps in our team because let's say an advanced programmer is doing something and they're about to go program, they can ask a rookie member, hey, can you get this set of phones ready for me? That way I can start programming it as soon as I'm done with this. Or at an outreach event, hey, these phones disconnected. Let's connect them back up really, really quickly. So by having everybody know how the configuration and the phones work, it makes your entire team more successful as a whole. So this is straight from my curriculum. I pulled this straight out of the curriculum that I created, and it's just going over the basics of block programming. So you can see on your right, you've got an action block, and it's got that little notch, the little V notch shaped puzzle piece on the left-hand side. And so that's the most simple action block there. It says front underscore left dot power to 1. And so the action block is set front underscore left dot power 2. And these are just action blocks. They do something. And one of the cool things you can do with them is you can attach data blocks, which are a value. So like a number, true or false, a string. And one of the cool things with this is you can change the effect of the action blocks by changing the data block. And that data block is considered a parameter. And you can see there, I just introduced the concept of a parameter, something that can be a fairly advanced concept um, to people doing block programming in the basics of block programming. I mean, the advanced concepts of programming are built in to the advanced concepts of programming are built into the basis of block programming. And learning block programming really sets you up to learn other programming languages really, really easily. And then we also have these math blocks, which take in data blocks and use the data blocks to create a new value that can be used as a data. So, I mean, all of these things, they exist in Java. There are functions, there are variables with types, and there are math operations. And you can do all of that in block programming. So, what type of block is this? Is what I would ask any group of people that I was training to make sure that they grasp what I was talking about. So this is an action block because it's got that little V on the left-hand side. And one of the cool things about it is it's got the parameter on it. So you can change the value of the power that you're setting to -1 and 1. And this is the simplest block, and it's the same exact block that's in Java. If any of you know Java programming, the syntax for setting motor power is dot set power. And here, instead of saying dot set power, they say set motor name dot power to. It's the same thing. So it's very, very similar to Java in that way. So let's compare blocks versus Java. Yes, this is going to have a little bit of I'm trying to compare the two. So blocks has logical errors, so there is going to be errors that you can throw if you program incorrectly, but it doesn't have syntax errors. It doesn't let you make the syntax errors because of the shape of the different blocks, which is really, really cool. Java does have syntax errors, and let's say you forget a semicolon, or let's say you forget a bracket, that can really mess up your Java code. So that's one of the nice things about blocks. Again, blocks wireless downloading. Being able to download your code in 5 seconds and test it out immediately is incredibly useful when prototyping and when programming. I mean, having that type of downloading really speeds up your development process and allows you to face less frustration because you aren't going to waste 10 minutes because you forgot 2 lines of code in your program. So with blocks, the reason why it's so fast at downloading is because you're only downloading the program that you work on. Well, if you do Java with Android Studio, you're downloading the entire application, which is a lot larger file. So that's why it takes longer, but you don't need that length. With blocks, you're just doing it very concisely. Blocks is a lot simpler to learn than Java in our experience. And the code is stored on the phone. So one of the things that we run into as Java programmers is, let's say I want to work on the code for the robot, but the main programmer isn't there, and the code is on his laptop. Then I can't work on the code for the robot because I don't have the Java code. He has it on his laptop, so I can't access it during the meeting, and then I just wasted the meeting because there's nothing I can do. The nice thing about blocks is the code is stored on the phone. So if you keep the phones with the robot, because the phones are the team's property, then that's great. The code's always with the robot, and you can edit it from whichever computer you want. And yes, I know there's ways around it for Java, like you can use GitHub and stuff like that, but that can be fairly complicated, especially for a rookie team. So by having the code stored on the phones, it makes it a lot easier for a rookie team dynamic. And yeah, there is no version control for block programming, and that's one of the downsides of it. But you can download the block programming code that you write to your computer, upload it to Google Drive, and just keep a repository of all your code. And that it does take some diligence, but it will allow you to keep backups of your code, and then you still have all the code on your phone, so then anybody can work on it. And blocks versus Java, installing Android Studio can be a very difficult task for many teams. it's a very complicated and painstaking process. So by only having Google Chrome, which almost everybody in the world has, um, blocks is very advantageous in that way. And since blocks and Java use the same nomenclature, we actually find that blocks is a really good way to learn Java concepts. So even though this year we've got some new kids on our team and they're going to be programming Java, they know Java from before FTC, before they joined this team, we're still going to have them learn blocks so then they can learn the concepts and the nomenclature that is in the FTC SDK, and then they can apply it to Java. And because of the quick downloading and because of it being very simple, we hope that they can learn it very quickly. And then when they get to Android Studio, they can start doing a little bit more of the complex things. So why not switch? I think I went to the right slide. Yep. So many teams ask us, why not do OnBot Java? And yes, OnBot Java's got the wireless downloading where you get less than 5 seconds to download your code, and it's got all the built-in capabilities of the SDK. That's one of the things that I want to highlight on blocks. You can do TensorFlow. You can do every single sensor that exists in the FTC SDK in blocks. One of the disadvantages to both OnBot Java and blocks is you can't do external libraries yet. So that does make it a little bit limiting, but we haven't needed external libraries ever. We use them just because we chose to, but there's ways around using external libraries, and it's not necessary in FTC. With the base SDK, you can do everything that you could to solve a perfect autonomous and to do a perfect tally app. TensorFlow allowed you to sample the minerals this year, and you could use Vuforia to get positioning on the field. So all of that is available in both OnBot Java and blocks. So there's not really any limitations there. In OnBot Java, we found that it's very easy to make syntax errors since it doesn't help you with writing the code. In blocks, the code just works. There's no way to make a syntax error. It'll either snap together or it won't. So that's one of the nice things about blocks. You don't have to worry about making syntax errors. And so you don't have to memorize syntax, which is one thing that you have to do in OnBot Java. So they're both very similar programming languages, but there's more memorization required for OnBot Java. So a lot of teams ask us, hey, we did blocks. Now we're ready to move on to Java. Do you recommend going to Android Studio or OnBot Java? And OnBot Java is an awesome tool. I am really happy that it exists because it's a cool tool for teams to be able to use. And again, it can be used for prototyping just like blocks is. But one of the things that makes me say go to Android Studio and makes our team never use OnBot Java is the fact that you have to memorize all your syntax with OnBot Java. It doesn't help you with writing your code. In Android Studio, there's a lot of helping that it does to make sure that all your functions will be right, all of your variables are there. It'll show you what the parameters of a function are while you're typing them in, stuff like that. Android Studio will give you a list of possible functions that you can pick from when writing code for a DC motor or for a robot that you create. OnBot Java also does not give you the exact line number of an error. So if like code malfunctions, OnBot Java won't give you the exact line number, which makes it very difficult to debug with. Android Studio does. And what we recommend doing is if you're trying to transition from blocks to Java, take your block code. There's a blocks to Java converter built into the SDK. It's a button. And then copy that code that's generated into Android Studio. It'll open up that code in OnBot Java, but just copy it straight into Android Studio and then delete it from OnBot Java. And that's how you can try to switch over from Java to block, or from blocks to Java. And you'll see that when you press that convert button, all the functions that you've used are effectively one-to-one. They're very similar to what you were doing in blocks, so it will be very simple for you to switch over. So there are limitations to blocks, and I don't want to say that it's the perfect programming language because it isn't. There's no such thing as a perfect programming language. It is great, and we will always use it, but here are some of the limitations that it has. You can't do external libraries, so the two main ones that are used in FTC are OpenCV and Roadrunner. Both of those won't work in blocks. But again, for a rookie team or for a second year team, even for a third year team, there's no need to use these external libraries. OpenCV can be easily replaced with TensorFlow, which had all the mineral tracking stuff in it. And then Roadrunner, you don't need it unless you're doing very, very advanced motion profiling. No custom I2C sensors. Again, in our time in the FTC, we've never used a custom I2C sensor. We've only used the sensors that are supported in the SDK. And the SDK is great because they're adding sensors that are commonly used by the teams. So like they added the NavX IMU, which is an awesome inertial measurement unit, which was great. Then we didn't have to write custom I2C code for it. Block programming also doesn't have an object-oriented workflow, which can make it difficult to make modular pieces of code. It's almost impossible to make modular code in blocks. And the code can also look like a mess if it gets too long and too crumpled. You can see that it becomes like long things of just colors and text. And so it can become very difficult to read. Only teams that need to make really advanced software need any of these four things. I mean, we have not needed them in the past, and I'm sure this year, if we wanted to, we could have gotten away with just doing blocks. We chose to do Android Studio because we wanted to learn some more advanced things, but all of our rookie members, they were learning how to program the robot in blocks because it's very simple to do, and they could do it easily. So most teams, you can get away with blocks. You don't need anything fancy like you get from Android Studio. So one of the things that I want to do is I want to show you an autonomous program. So if you look at the robot that's in the center of the frame right now, this robot competed in Relic Recovery. So one of the things I'll talk through what it does throughout the match. So you can see that it was able to knock off a jewel. So it was able to push off the correct jewel. It uses sensor. It used the Vuforia target to place the glyph in the correct target. And now it's going into the glyph pit, picking up a glyph and dropping it off into the column. So we did a 2-glyph autonomous with sensors. We were able to use Vuforia to scan the vision target and a color sensor to detect the correct jewel. And we went into the pit to pick up additional glyphs, which was like the gold standard for FTC last year. And that was all done in blocks. We didn't use a single line of Java code for that entire autonomous program. And that was the highest scoring autonomous program in Maryland for until the state championship. So this is the power of blocks. You can do everything that you can with Java in blocks. There's no need to use blocks. You can score just as, or no need to use Java. You can score just as high with blocks, and this is proof of it. And the reason why we did use blocks in this was we were trying to do some advanced things in Java, and we ran out of time. Our programmer didn't get it done in time because of how long it takes to develop in Java. And so in blocks, we were able to very quickly make this program. I think we made this program in less than a week, and it was up and running for the competition. And it wasn't only this run that I got perfect. It got perfect multiple times. So what can you do in blocks? This is exactly what I'm talking about. Accurate encoder movement. So all of those motions were using the encoders built into the motors. Color detection for the jewels. We were able to do accurate rotations using the Rev inertial measurement unit, or the one built into the Rev hub, and we were able to detect the VuMark using Vuforia. So, I mean, it's awesome. Blocks can do everything that you need it to do. And so we're trying to show you can do everything that you need to in blocks. So things that you can do in blocks. You can do accurate motions. I mean, the same accuracy that you're going to get in Java, you can get in blocks. You can write PID control loops in blocks. You can do encoder motions in blocks. You can have the same sensors, all the Rev sensors, most of the modern robotics ones, color, ultrasonic, touch, magnetic. Everything that's commonly used by FTC is supported in blocks. And you can use the phone camera, which is considered the most, I guess, complex sensor. You can use Vuforia and TensorFlow with it. And it's not just the phone camera. You can also use the external USB cameras now with blocks, and it works just fine. So, I mean, these are all great reasons that you can use blocks. And also, if you have any questions during this, just send a message. So, learning Java using blocks. So, I briefly touched on this before, but the nomenclature used in blocks is the same as used in Java, which is really great for learning because you can just take what you learned in blocks and apply it directly to Java. And you can press one button to convert all your code into Java, which is a pretty nice feature that they've added to the SDK. All the same functions are available in Java. So let's say you have a motor function that's built into the SDK, like set position to, or set target position. That function is also available in blocks. All the functions from the IMU, get yaw, get pitch, those are all available in blocks. So all the same functions are available, and you can use blocks to learn the programming concept, and especially how it relates to robots, because programming a robot is different than programming a computer. So learning how programming concepts work for robots, and then apply it to Java and learn the advanced programming. So block also comes in with pre-made programs, and this is one of the great things that I think FTC has done to promote it, is I was able to get a TensorFlow program running within 10 seconds because they have all these pre-made programs there to show you how to do everything. So they have one to show you how to do sampling. They have one to show you how to do a tank code. So these pre-made programs are great for learning because you can see how how they do it, how FTC does it, and then you can use it in your own code. You can even copy and paste straight from there, and it's a great way to learn. So resources to learn block programming. We've created a video series on how we program that perfect autonomous in Relic Recovery. And it walks you through exactly what we did in order to do that and create our accurate motions and all of the other stuff involved. And FTC has also released some tutorials on how to do different things in blocks, like access the IMU, set motor power, stuff like that. And there's also the sample programs built into blocks, which show you how to do different cool things like TensorFlow or using the IMU or using a color sensor. They have concepts for all of these. That way you can see how to apply it to yourself. There's also a really good detailed block programming training guide. It's not a video, so you have to read through it. It's like a PDF, but it's very thorough. And now I'm going to share with you our resource that we've created, which is the curriculum. Before we do that, I'm also going to talk to you a little bit about how blocks is continually improving. The support that we've gotten from the First Tech Challenge headquarters is incredible when it comes to blocks. The interface of blocks is being constantly updated, which is a little bit different, but they add new features every year. They added TensorFlow this year. They added the IMU last year and Vuforia last year. They added the blocks to Java converter this year. They added sample programs for every game to help you solve the objectives in that game. They're giving you the code in order for you to be successful. So it's very resourceful, and there's a lot of resources out there in order to help you with blocks. So this is the blocks UI in 2017-18. You can see on the left, you've got the different types of blocks. In the center is where you place your blocks, and then you've got a general UI. It's a little bit different than the 2018-19 blocks UI, but it's got the same structure. So on the left, you've got all of the different types of blocks that you can pick. In the center, you've got where you place your blocks, and then on the top, you've got some save and other functions that you can do. So even though there is a difference between them, 2017 versus 2018, blocks isn't changing that much where you have to relearn a new language. It's just adding stuff that increases functionality. So now I'm going to talk to you about training and our resource that we've created, which is a block training curriculum called Connections, Configurations, and Coding, which walks you through connecting up your robot, configuring it, and then coding it using block programming. So we're going to expose our secret spells for a successful training. So having this is what our outline is in our training session. So first, we teach people about the control system because we find that without knowledge on the control system, it's almost impossible to program in any language, let alone like even blocks. It's very difficult to program in blocks without understanding how the control system works. So understanding how there's a rev hub, how there's phones, how there's USB cables, how there's power cables, sensor cables, stuff like that. Just understanding that is the first thing that we do with every training. And we'll spend as much time as we need to for the audience to grasp that because it's one of the most important key concepts. Next, we teach teams how to configure their robot. So we'll give them a factory resetted set of phones and tell them, get the robot configured. So that walks them through um, renaming their phones, pairing their phones, creating a configuration file and a hardware map for their robot, and stuff like that. Next thing we do is we show them the block programming interface and the different aspects of it, like I did on the previous couple of slides. After that, we create a simple tank mode. So we don't use pre-made code. Pre-made code's a great resource, but we have them created from scratch. So we walk them through the pseudocode. We just state in English what we want the robot to do. And then we let them code up their tank mode. And it's awesome because the students are really, really excited to see their robot move. We're usually able to get the tank drive within half an hour to an hour at the beginning of our training. And so teams get really excited at this time and they're ready to just hop right in. They want to get deep into block programming. They want to do more advanced things and cool things. And so it's very inspiring to them. And I think that's the main takeaway from block programming. It's not just a tool, it really inspires the kids to continue on because it limits frustration. Um, Next, we talk to them about motor behaviors. So, how can you change the motor behaviors like the zero power behavior or the different motor modes and stuff like that? And then we start talking to them about more advanced programming concepts that apply directly to Java, like variables. You can create functions in blocks. You can use different sensors in blocks. So we'll talk to them a little bit about that. But the intro part is the key thing. And one of the things that I do is in the advanced, part 7, the advanced programming concepts like variables, functions, and sensors, I try to tune it to the year's game. So I'll talk a little bit about that in a couple of slides. So now you're ready to teach your team and others. Like I said, the first part is not programming, it's the connections and configuration part and understanding how your phone all connects up. Understanding how the control system works is more complicated than block programming. I said it before. Understanding how this entire FTC control system works can be more difficult than programming itself. So here I've got the link. If you see on the screen, I've got the link to the curriculum that I've created. I will also post it in the chat in a couple of seconds at the end of the training. And I will also have a QR code up. But this curriculum has all of that. So it teaches you how to connect, configure, and I've got screenshots of every step in order to help teams along the way. So configuration. Many teams struggle with keeping a proper configuration. Let's say on one set of phones, they have a configuration where the robot has a motor called right front. And on the other set of phones, they've got a configuration that has a motor called RF or R front or right F, something like that. What we do is we created this Excel sheet, and this Excel sheet's also public. It helps keep good naming conventions, and it helps us keep track of what our configuration actually is. So at our trainings, what we do is, because it takes too long to actually trace every single wire, we create these configuration templates beforehand, and we give them to the teams so that they can just type everything in straight from the spreadsheet. And this really helps speed up process during a training, but it also helps speed up the process during an actual the entire competition, because you will be able to keep track of what the names of all of your hardware components are. So what makes a successful block programming training? And I don't want to scare you by any means. You can change this as much as you want. This is what we've done in the past. What we do is we get drivetrains and laptops. So we try to get one drivetrain and one laptop for every 2 to 4 people. And these drivetrains are not just for this training. What we do is we have rookie members build these drivetrains. That way they can learn over the summer how FTC works, how to build stuff, and that. And then we use these drivetrains for the training. What you can also do is ask teams that are attending to bring a drivetrain, bring a robot to the training, and um, bring their laptop. That way, you don't have to use your resources, um, and other teams are helping you along the way. Um, we've just had the drivetrain, so we've been able to do that, but there's definitely multiple ways to do this. Um, we also like having a large space with projector. Having a projector allows you to present the PowerPoint slides and the curriculum that I've created. And having a large space is nice because then you can drive the robot around. Initially, it might seem daunting to give a presentation in a large space because you have to be shouting the entire time. But having a large space really allows kids to get engaged because they can just drive their robot around and without worrying about anything. And then they can also just change the code really quickly because they like to tweak with the code that they've made and try changing out variables and see what happens. So having a large space is nice for that. We tried doing it in a computer lab once, but it was difficult because we would have to go outside in the hallway in order to let the teams run around their robot. And then they would have to come back to change their code, and then they would go back out in the hallway, and it just took too long. We say ideally 3 people per demo robot that they're going to be using, 3 to 4. Um, I think that's good. And having a coach or mentor to help younger teams, especially middle school teams, is very, very useful. So if you know that a younger team is coming to your training, just let them know. That way they can be successful, and also the coach can learn. So if there's anything that they didn't grasp, they can go through it again with their coach. Um, we try to have one presenter in the entire training, and then we have one helper for every 2 to 3 groups. So we don't limit it to only just one person giving the presentation. We try to get 4 to 5 people on our team there. That way, each group can get individualized attention because not everybody's going to run at the same pace. And sometimes you're going to have phone errors, or sometimes you're going to have USB errors. So having a helper there to help guide a team through is really useful. So we say one for every 2 to 3 groups. So preparing the demo bots. So this is how we get our robots ready for training because this is actually part of the thing that helps other teams learn. So we wipe the phones to factory state. So we don't. We're trying to simulate what it's like for them when they get their robot kit at first. So we factory reset everything. We pre-install the driver station and robot controller apps because there might not be Wi-Fi at the training, but everything else is factory default. And this allows them to learn how to configure the robot from start to finish, that like they would be doing on their own phones. And then we also create the sample configuration sheet, that Excel file that I showed you earlier, for every team. That way they can use it for their robot. We try to have a laptop with Chrome installed on it for every robot there. That way they can, they can program the robot. It's hard to share laptops, so having at least one for every robot is a good thing to have. So this is the hardware configuration sheet again. Try to have these for every single robot that's there that you're bringing. If another team is bringing their own robot because you don't have robots or something like that, then that's fine. But this just helps us run a little bit more smoothly because they can just look down, hey, in port 1, I've got right_front. Or in port 3, I have left_front. And that way, the code that shows up on the screen from the curriculum is also the same code that they're writing because all the naming is the same. So tips for presenting. I practice on my team members all the time. So I've given this training, I think, 3 or 4 times now. And every year I'll practice on my team members just to make sure I'm getting the hang of it. Especially rookie members, they're literally your audience. They're literally the people that you're going to be training in a competition, in a training session. You want to make sure that they grasp all the concepts. How our workflow has worked in the past is I show teams how to do whatever we're doing on the screen, and then I let them go at their own. And I leave the steps up there on the screen. That way, if they need help, they can just look up. But I try to have them go on their own and not just follow step by step. So I'll show them, hey, do click on Wi-Fi settings, then click advanced settings, click Wi-Fi direct, and then forget groups. And then I'll have them do that, and I'll have the helpers go around making sure that they're okay and that all the teams are good. And then once all the helpers give me a thumbs up, I go on to the next step. So it's we show them how to do it, and then I take a break, and they do it, and then we get back together. That's the workflow that we found very useful. So this is just an example, straight from the curriculum. This is to get motor up and running, I believe. So here you can see if you click on DC motors on the left-hand side, there's going to be so many different blocks. Don't worry about that. Don't be scared. These are all just things that you can do with the DC motor. We're going to select the direction block. And this is because we had talked about this earlier in the presentation. We have to reverse one of the sides of the motors. And you can see that there's this name on the screen. That's just a random motor name. Don't worry about what it says right now. We can change that later. So next, what you're going to do is you're going to drop it into the initialization blocks, right underneath the initialization blocks where you see in the picture right here. And you're going to pick whatever name it is. So in this case, we're going to pick right back. And we want to set the direction to reverse. And so then I would take a break. I would make sure that everybody got to that step, made sure that everybody had the right back to reverse, and I would have my helpers check to make sure that they're all good, and then we would move on to the next step. One of the things that I like to do during the presentation, like I had touched on before, is brainstorm on the year's game and how they can apply it to what they're learning in blocks. So especially when you get to the advanced sensors and stuff like that, in Relic Recovery, what I did was I gave a color sensor training because that was the most common way to detect which mineral was, or which jewel was on which side and knock off the correct jewel. Last year, I gave some TensorFlow training. I showed them, hey, this is a resource that you can use in order to detect which mineral is where. And I also taught them about how to use servos because a lot of teams were using a servo to drop off their team marker. So making the curriculum for the game really helps. I will be constantly updating the curriculum so that it fits the game as soon as they release the game this year. So now our presentation is coming to a close. I'd be happy to take any questions. I'll be on for probably another 5 to 10 minutes. But what we had set out to do at the beginning was we wanted to go over what block programming was. And then I showed you how it really changed my team and what you can do with block programming, because it's not limiting like most people think it is. It's a very powerful resource. And then I also showed you where you can go to learn about block programming and teach yourself block programming. And then I also talked to you about how you can train others and your team how to use block programming. And this is really what I want to hit on. I mean, block programming is such an undervalued resource in the FTC community. I think it can really change teams like it did my own, and it can really keep people in the first program and make first a life-changing experience for them. So by training others in block programming, I think you're really going to be changing lives. I know I've touched a lot of people through block programming, and I've really helped a lot of people stick with FIRST and stick with STEM because of it. So it's a rewarding experience to train others in block programming. And you're not going to be alone on it. If you ever want to train in block programming, just send us an email, talk to somebody, and we would be more than happy to help you with giving these trainings. Ideally, I want block programming in all 50 states, in all countries with FTC, because it's that useful of a resource and it's just not known about right now. So thank you to everybody that's contributed to this conference, past and current members of Wizards.exe, mentors and coaches for Wizards.exe. One of the people that I want to highlight is Mr. Toam and the FTC tech team. They've done an awesome job with block programming and making sure that it's supported with Java and making sure that people are aware of it. And Miss Liz Looney and the entire Google Blocks team, she was the one who had the idea for putting block programming in FTC, and it's been awesome for our team and many others. So I'd like to thank them. I'd like to also thank all of our sponsors from last year. Without them, this would not be possible. And I'd also like to thank the conference sponsors who made this conference possible at the Detroit World Championship where I gave it. Without them, again, I probably would not have gotten to make this. Thank you guys for all tuning in. If you have any questions, just send us an email at Wizards.exe. That QR code, I believe, let me double check, should lead you to all of the block programming resources, my block programming curriculum that I've created. So if you're interested, let me just double check. Go ahead and scan that QR code, and you should be able to. Oh, so that QR code leads you to this presentation, and there's links in this presentation to the curriculum and stuff like that. So thank you very much. And I see I got a question from Precision Cutups. Can you do some form of version control in blocks, something like Git or maybe Git itself? So blocks does not have integration for Git or SVN or whatever other version control you're trying to use. But with blocks, you can download all of the code. So every time you make the code, what you can do is download the code onto your computer, upload it to Google Drive. So every time you make a change, you just upload it to the Google Drive. It does take some dedication in order to make sure that it gets uploaded there every time, but it is a way of doing version control to make sure that your code, let's say you make a change that doesn't work out, you can revert back to the previous version of the code. Sharing with blocks is, again, very easy. You can share that entire folder that you create on Google Drive, and then the code stored on the phone, so you won't really have a problem sharing the code, the latest version of the code, with other students. Any other questions? I'll be here for another 5 to 10 minutes, so if you've got any, just let me know. All right, if we've got no more questions, I'm not seeing any more in the chat. Thank you guys all for coming out and dealing with all the technical shenanigans. I really appreciate you guys coming out. This stuff is really what drives me. I hope that you guys all took something away from this presentation, and you guys will hopefully one day run a block programming training session. If you guys have any questions, as always, just send us an email at Wizards.exe and visit our website, and we'd be more than happy to help you out. Thank you, guys.